I'm Caleb, and together with the rest of Team Goose have created Pitch Perfect. With the surge in popularity of domestic camping holidays, we wanted to create an app that distinguished itself from its competitors by providing access to all campsites in the UK, not only those willing to pay the eye-watering commission of existing booking platforms. Pitch Perfect is an app designed to simplify the camping experience by providing a clear list of campsites based on either your current location or by a location of your choice, once we're allowed to go further afield. When choosing a campsite in the unnervingly unpredictable climate of the UK, there are a few things that hold great importance. How close is the nearest pub, and can I walk there? Can I make it to the nearest cafe before it starts raining? And is there a supermarket nearby for that thing that I have most definitely forgotten? With Pitch Perfect, this information is instantly available to you on either your mobile or desktop, along with photos, ratings and reviews, so you can decide on a campsite to stay at with greater ease. Now it's over to Tomasz with a demo of our app.
Thanks, Caleb. Hi everyone, my name is Tomasz. Here is a homepage of our app. When you first open the app, it will show you all the campsites on the map in the 30 kilometers radius from your current location. Each campsite in your radius is given an interactive marker, which, when you click, takes you to its place on the list. This gives you some preliminary details about the campsite. I'm able to change the location by using the search bar, and this will only accept places inside the UK. The list of campsites is updated and I can now browse through them. When you click on the name of a campsite, you are taken to a dedicated page, which displays the address and contact details at the top, and little further down, photos and the nearest pub, cafe and supermarket, distance and walking times to each. Scrolling down, there is a section of reviews. These are left by Google and Pitch Perfect users, as this is integrated. Using the search list bar, I can go back to the search results. In the login panel, I can either sign into an existing account or create a new one using the register form equipped with input validation. Now I'm going to log in as a user that already has some booking information from our database. After logging in, I can go to the user account showing me all the details. Here is where we display upcoming and previous bookings and the ability to change your password, contact the owner, cancel bookings and leave reviews. Features we would implement given more time. Now I will pass you over to Dong, who is going to talk about backend aspects.
Thanks Thomas for the demo show. A lot of functionality in our app relies on strong backend support. My name is Dong. I'm very happy to introduce our SQL database and APIs we have at this moment. We have developed 5 tables to store our data, including users, owners, campsites, camping history, and reviews. Users and owners tables are independent, but other tables will have reference to some columns in different tables. For example, camping history table has username and place ID as foreign keys with reference to users table and campsite table. The place ID in our database is consistent with that from Google APIs, which makes it convenient to fetch data from Google Library or our database. We already have 13 fully tested APIs, and we host our backend on Heroku. Here is the base URL for our backend APIs. By these APIs, we can post new users to database, we can get the reviews from database as long as you specify place ID, and some others. Next, Steve will talk about the tech stack in this project.
Good afternoon, my name's Steve and I'd like to talk to you about some of the tech choices that we made on the front-end design of this application. And obviously this was a React app, which we chose in order to be able to deploy to both mobile and desktop versions. But within that there were a lot of packages and libraries that we used, and many of them we were using for the first time, such as something as simple as React Bootstrap, which was great for reusable components like drop-down menus, buttons, things like this. But for many on the team this was the first time we've used it. But the big one was GoogleMaps React. And this was a fantastic package for both rendering the map itself and also for making the requests to the API, because GoogleMaps React has many built-in functions which can avoid having to write out these long URLs that something like Axios would require. And of course there were the Google API libraries themselves, and which we had to explore. There are many, many different ones, and we ended up using Google Places because it allowed us to do fuzzy search on a generic place name. which would then give us the geolocation, which was kind of the last thing that we really had to get to grips with, both the user's own geolocation and those provided by the Google API. And these were a fantastic learning experience implementing these in our application. I'm now going to hand you over to Dan, who's going to talk to you about some of the backend choices we made as well.
Thanks, Steve. So hi everyone, my name's Dan and I'll be talking about our tech choices for the backend. For our backend API, we decided to use Node, Express, Knex and PostgreSQL. We decided to use Express to set up our servers, as we all had some experience using Express from our time throughout the bootcamp, and believe an Express server would be the perfect server for the different type of requests we were making to our API. Once we had made the decision to use Express, we then had to decide what language we would use to store and manipulate our data, which is when we all came to the decision to use SQL to set up our database. The reason we decided to use an SQL relational database was because a lot of our data on the database was related to each other, so we could use join and other SQL methods to merge some data together, such as the users table with the camping history table and the owners with the campsites table. Although we could have used raw SQL for our data requests, due to us using other JavaScript frameworks and libraries as stated earlier, we decided to use Knex and PostgreSQL to retrieve and manipulate our data from our API. We also had a decision to make as to which online map API we would use. We discussed the possibilities of this in a stand-up one morning, and three of us spent a morning researching different online map APIs. The final three options were Mapblog, TomTom and Google Maps. After spending some more time weighing up the positives and negatives of each separately, we had a group meeting to discuss them. The reason we didn't use Mapblog was due to only being able to search within a 1,000 metre radius around an inputted location, which wouldn't work for our app as we show the user campsites within a 30 km radius. This then left us with TomTom and Google Maps. We eventually came to a group decision that Google Maps API was the best choice, as it allowed us to use it for everywhere we needed, and there was so much information we could get from a request to it, such as reviews of local campsites, photos and point of interest nearby. During the 3 weeks we spent working on our web app, we did run into a few issues that needed some good problem solving skills to fix, and I'll pass back to Steve, who will discuss how we face these challenges as a group in an agile way.
Thank you, Dan. Yeah, throughout the development of this application, we faced many of the challenges together as a team, not just through the stand-up meetings in the morning, something which became invaluable as a form of communication between all of us, but just in the collaboration to create some of the design tools at the start, such as the mind map you can see here. That took many different members of the team working together to get everything just about right on that. And you've also got Figma down below. This was used to create wireframes to really show the design to everyone on the team, and that was an incredibly useful tool which allowed us to get the app looking as good as it does. And all of these were built up by many of the team working together. I'm going to hand you over to Caleb, who also has another example of us working together as a team.
Thanks, Stephen. Another challenge we faced as a team was dealing with an unknown API and its unpredictable behavior. We found that even though our map contained no campsites, our list was showing as if there were. This was a quirk of the Google Maps API. It didn't limit its results based on our specified radius. We researched in pairs, shared our ideas, and then implemented a separate library called Geometry, which allowed us to compute the distance between the center of our map and the location of each campsite in the search, and to only display the results that fell inside our search radius. Problem solved. And now back to Steve to round us off.
Thank you very much, Caleb. Yeah, just one last thing at the end of the presentation is just to say that we had initially intended to allow users to post and delete reviews on campsites, and also to vote on campsites through the camping history on the user page. We did actually get the backends for this set up. Myself and Dan, we've got all the endpoints, the post, the patch, the delete. That's live, that's active, that's set up now. We just needed a day or two to get this implemented on the front end and to get the design work completed, but we just ran out of time at the end of the project for this. On that note, that brings us to the end of the talk today. On behalf of everyone here at Team Goose, I'd like to say thank you for listening to our presentation on Pitch Perfect.